we go. We got a good sized group. So why don't I share my screen? I don't have a lot to say. Stu's going to do all the talking tonight, right, Stu?
Yeah.
Yeah, the only thing I have here is the topics coming up. I'm doing pretty good at filling things out, I believe. Of course, this is all tentative, but it looks as though we've got something planned at least out through August. So that leaves the last quarter. Next time is Greg Krinklaw is the author of Sky Tools. And I used to use Sky Tools 3, but I have never tried Sky Tools 4, but he's planning to give us a lecture on Sky Tools 4. I don't know how many people are using it, but it's a pretty powerful tool. It's really, I think, pretty completely done. In May, Jerry Hilburn's going to talk about asteroids. I don't know if how many of you know, but Jerry, moved up to Central California a few years ago. He still, on occasion, came back to his observatory at TDS, but he really kind of longs for his observatory, I think, and he's actually mostly moving back down to San Diego, and it's going to be trying to get people involved in some of the things he's doing, and of course the most prominent thing is asteroids. So he's going to talk to us about asteroids, I think in May, perhaps in June, I don't know. And then Bill Jacobs, are you on the meeting here or not? I can't tell. But anyway, Bill's one of our members, and he's put together a very good briefing, I believe, on how to image that's kind of aimed at beginners and a little bit, and he wants to talk a little bit about Python, which is, that's really not beginners, that's programmers, of course. Then in July, I'd like to see the group pick an image, some nice summer DSO object, and we can all image it and see how the images turned out, just like we did last year. I think the process last year went pretty well. And then in August, Dave Wood and I have talked about using one of the tarot images and doing the same kind of thing that Stu's going to show us today, but having the whole group do it and present their results. So that's kind of what's coming up. And that's really about all I have to say at this point. So why don't I stop my share? And Stu, can you pick it up?
Sure.
I need to do something here with the share. Why don't you try?
I got it. If you let me share screen. Yeah. Okay. So
Okay.
I met many of you both in person and at AI Advanced Imaging Conference. I'm a native San Diegan. I grew up there, still have a house down there. But I live up here in the Bay Area where I currently work. But I've been involved with the San Diego Astronomy Association for many years. Mostly was introduced by Mike Chasen, who's a good buddy of mine. And Mike's been very kind in spending all my money. When I was learning, when I was buying equipment, Mike says, because you don't need that equipment, you need this. And several $1,000s later, here I am. The data that I'm going to show is actually data from Tarot. You can download it yourself and work on it yourself. It's available from David, and he did the Christmas Tree Nebula, HA S203, and then LRGB. I am not going to be using the S2 and 03, but I'm going to be showing you HA LRGB combinations. So the first thing I want to share is a lot of this comes from the Masters of PixInsight course that is run by Warren Keller, Ron Breacher, and Pete Prue, who I'm sure you're all familiar with. They did a workshop on working with narrowband data. And in this workshop, they used the Tarot data with permission from David Wood. And in turn, I'm going to be showing you some of the techniques that they showed there. I'm doing it slightly differently than they did in the workshop. So if you are at the workshop, and I'm sure some of you were, I'm doing a little different than what they did in the workshop, but it's going to be similar. So let me just now get out of this and share go to the meat of the matter. So we'll go to PixInsight, and I'm just going to run through sort of run through, but sort of walk through the process. And I've set it up some already, and I've already processed these, but we're going to reprocess these again. And so we have our HA, our Loom, and RGB, and I already cropped it and combined it. And this is obviously in linear state, and we'll do an STF on this. And we can see that its linked STF has a green cast, and this is entirely normal. We'll do an STF here on the luminance, and an STF here on the HA. And we can see that the luminance and HA look quite different, because here we have the big star with the halo, and here we have this really pretty fox fur stuff. So what we're gonna try to do is to get that fox fur stuff into the color. So the first thing that we have to do is let's unlink this screen stretch so we can see it a little bit better. And again, I'm just going to be walking through this. And if I say stuff that you don't quite understand, you go ahead and ask, like linked, unlinked, what I mean by that. I'm going to assume that a lot of you understand this, but if you have a question, you don't understand what I do or what I'm talking about, then feel free to stop me in the middle of it. So the first thing I'm going to do is the dynamic background extraction. And here, what we have to do is we have to find, there's not a lot of background in this. A lot of this is signal that we want to actually keep. And there's a couple ways to do this, where you can take do a dynamic background extraction on one image and then apply it to another image. And I'm going to start here with the RGB. The first time I did it, I started with the HA. This time I started with the RGB, and we see I've put in 6 or 7 points here. So 1, 2, 3, 4, 5, 6, 7. I have a pretty large radius because I want to get a lot of background. And let's just take a look at the background model itself. So the background model, go ahead and stretch it. We see here that the background model looks pretty good. We see gradient in there, but we don't see any structure. So I think it's okay to use this particular model for the for our background extraction. And so we'll go ahead and apply this. We've already seen the background model, so I'm going to discard it. And so recheck it, and there's our background extracted, and it looks more or less similar, but the color cast is is different if you go backwards and forwards. So it's a little hard to see, but you're going to just trust me on that. So we'll use these same points to do the background instruction on the HA in the loom. We do that. I can create an instance icon here by dragging it to the desktop. I'll close this. It'll give me a bleep. And I will open up the loom. I will, again, we'll do a none, have a look. So it has the same points as it did on the RGB. Apply, and we look and we see it's a little bit of structure, not too bad. Maybe I'll take this point out, take a look at it again. Maybe a little better. But a lot of this, when you're doing this, is a little bit of trial and error, trying to find what background looks that you basically are getting rid of gradient, but not structure. So that's a little bit better there, where we're just seeing gradient and not structure. And you just have to move these points around a little bit. So again, we'll apply this. Okay, fine, be that way. Okay. And we'll, again, stretch it. Close this. And we could do the same thing with the HA, but the HA doesn't, usually doesn't have a lot of problems with gradient. But since we already did it, we can just go ahead and apply it. Have a look at, same thing, have a look at the gradient. Once again, it's got a little bit of structure, so we'll take this guy out, try again.
So you're using the same sample points?
Using the same sample points, but I'm moving them around a little bit. Just
yeah, because there's the nebulosity is all over on the.
I know it's a little hard, isn't it? Maybe a little better. Okay. Okay. All right. So I'll close that. And nope. Then we'll go back to the color here. And the next step would be to do a linear noise reduction. Actually, no, I take that back. The next step is to do background neutralization and color calibration. So some people like to use PCC, photometric color calibration. I prefer using the old-fashioned background neutralization and color calibration. It's a little faster and I trust it. So here's a good sample of background. Target image, we're doing RGB preview 1, apply. Okay, it's done. Next, we'll do color calibration. Use the background reference. I use the same background reference here. And I like to output the white reference masks to make sure that I'm just getting white. So I'll go ahead and apply this. And two images will come up. So one is the color calibrated image, which is this. And then the other is the white reference mask. We look at this and this looks like, just looks like stars. So this is pretty good. I think we're okay with that. So go ahead and close that. We don't need it anymore. Close this. We don't need it anymore. Get rid of the preview because previews are annoying. And now we go to linear noise reduction. Now, I usually start the linear noise reduction a little bit more aggressively than this, usually 4, 3, 2, 2. With these settings, 5, 3, 2.5, and 1.5. I found that with this image, I didn't need quite so much because the Terra data is actually really quite clean. So if we just go to a preview and open up a preview here, and just look at the preview, and we'll just apply it to this preview here. And that looks pretty good. So we'll do, here's before, after. See that? Before, we have the noise there, after. Still a slight bit of crunch, but not too bad. We can take care of that later. I prefer not to over noise reduce in the beginning. So we'll go ahead and apply this to the whole image.
So you're doing this in the linear mode, right? And
this is linear. We have
yeah.
not gone non-linear. This is linear noise reduction, exactly,
Yeah.
at MLT. And these are modifications of settings that was provided to me by Warren Keller and Ron Breacher. And I do recommend, if you guys have the time and interest, to both Warren and Ron will do one-on-one tutoring sessions. And a number of people in my club have done them, and they are super helpful. I've done them a couple times. And they'll do one-on-one tutoring sessions and basically go through an image. You send them that's how they had this tarot image. I sent them to Warren. I did a one-on-one with Warren, and then with David's permission, he used it for the workshop. So highly recommend it if you can, if you have the time. Again, get rid of the preview here. All right, so we've done our color calibration, background neutralization. We've done our MLT. It's time to stretch the image. So here's our auto stretch. We can link it, and we can make it a little darker if we want to. Open up histogram transformation and drag it over to the histogram, and we see what our new histogram is going to look like. Ron Breacher likes to talk. See this? So we have the heavy line there and a dotted line there. Likes to put the majority of the histogram at this dotted line right there, and we can move that over a little bit so it's there. Apply. It'll turn white. Now it turns white because our screen stretch is still on. Get rid of the screen stretch, and now we're at a non-linear. Now we're non-linear. Okay. So we know we're non-linear because this is we don't see this green thing anymore. All right. So we'll adjust our black point a little bit, a little darker, just to control this halo area here. And then let's leave this for now, and let's go to our luminance. So once again, with our luminance. So here we are. We did our dB already. Everybody remember what the next step is? Noise reduction. So we'll do our MLT. One thing I did forget to show you was the mask. You can preview the linear mask that comes with MLT, and that's pretty good there. Oops. Okay. All right. Now we'll apply. I'm just using the same settings that I used for the RGB to save time, but I normally would go through this and adjust it. So once again, we'll go to the random area, before, after, there, okay. And then we stretch again. So screen transfer function, and I will go to my histogram transformation, move it over. It's a little hot, but that's okay. And we'll apply it. So again, then get rid of the stretch. And that's pretty good. So we're kind of right on target. So it's this first line we're looking at. This is the Ron Breacher line, I like to say here. And if we compare that to the RGB, it's more or less the same brightness. So if we look at this and we look at the RGB, maybe the RGB is a little dimmer, so we can make that maybe a little hotter.
Stu, could you go back and explain those two lines in the when you're doing the stretch? I don't see the dot on.
Okay, so if you look at the histogram transformation, you see a line here. See this line there? The
line going up and down.
The grid lines.
I see the grid lines, yeah.
Okay, so you see tic-tac-toe kind of grid lines. So there's the solid lines
right
here, and there's little dotted lines in between the solid lines.
Let's see, that doesn't show at all.
Oh, it doesn't? Okay. Well, trust me, there's little dotted lines in between.
Okay,
so
if I squint a little bit, and they're right in, they cross right in the middle of the squares, right?
Right, exactly. So
yeah, about the 1/8 line. The prominent ones are measured.
Yeah, it's like the 1/8 line, exactly.
Okay, and then how are you setting it when you do the stretch?
So I'm just sort of doing, so the majority of the histogram sort of lands at that line. Okay, so I still have it's not completely black.
At the first line, at the first dotted line, is that where it's, okay.
Yeah.
I see.
And you can just, it's basically, you can do it just to choice. But this is, this is basically a good rule of thumb. The other thing is you want to make what Adam Block likes to say is when he's doing these LRGB combinations, is he likes to have, he doesn't want to have it too, wants to have it too bright, because if you have it too bright, it's going to be saturated. So here we have most of our stuff is around 50%. So you see where the line's bouncing around there?
Yeah. That's the line.
It's around 50 to 70%, which means that when you try to saturate it, it's going to saturate okay. If you try to saturate somebody, if it's too hot, then it's not going to saturate well because the pixels are all saturated.
Mm-hmm.
So this is pretty good. So what we're going to do is we're going to do an LRGB combination here. So get our LRGB out, drag the luminance to the Lume tab, uncheck these puppies, RGB, and we'll apply. Okay, so now we have an LRGB combination. Now it's okay. It probably could use some saturation, but what we really want to try to get is this kind of fox fur stuff into this, and we're obviously not quite there yet. So I'm going to put the RGB aside, and we're going to turn our attention now to the hydrogen alpha. So hydrogen alpha, we've already done our background extraction. We will do our noise reduction. The other thing you can do is you can just drag an instance icon onto the process. So that, you can open it up and then drag it. But if you just take the instance icon itself and drag it, it'll go ahead and go. And I know I already want those settings because I've already used the settings and they were fine. So here we are. down, down. Let's kind of scroll in, kind of look. It probably could use a little bit more, but that's okay. So before, after, before, after. Okay. And then we'll do our screen transfer function. And again, set it, drag our screen transfer function to the histogram there. We can go ahead and apply it, undo the stretch. And it's a little bright, so let's darken it some, like this. And so now we want to be able to, the problem is we can't really combine this hydrogen alpha with this RGB, because if you look at the star sizes in between these, okay,
Yeah.
the star sizes are very, very different, okay? So you want to try to combine the best between this luminance and this hydrogen alpha here. So several ways to do it, but one thing we're gonna try is use pixel math. And we're gonna do an expression here, max HA comma lum, okay? So it's gonna, but what this basically does is this pixel math expression is it'll take the maximum, it'll go pixel by pixel and check whatever's the maximum here and whatever's the maximum here, and then put them together. I'm going to rescale the result and create a new image, and I'll drag it. What happened? No such image. Oh, that's what it did. So it wants, if you haven't used pixel math before, it needs to be exactly, it's case sensitive. So what it didn't like is that I had put a little underscore here. Okay, so now I'm going to do it again, rescale, create new image. And there's our combined image. Now let's compare them.
So that's the max of either one of the two.
That's the max of both. So if we compare these, we see that here we've got a little bit more of the fuzziness, and you can adjust this however you like. So if you wanted to make this HA a little hotter, say, and I think we made it so, or give it a little more contrast. They usually are pretty contrasty, but just to show you the difference. So here, so make it hotter like this, say, okay? And then do the same expression. So max HA comma lum, create new image, rescale.
Stu, I have a question. Does it matter if you apply it to either the HA?
It does not matter. If you're creating a new image, it doesn't matter.
Okay.
So we can see here that the HA is a little hotter. So we can decide what one we like the best. I'm just gonna stick with the first one because I generally like softer images than more in your face images. But it's basically, you know, whatever you prefer. And this is sort of where the art of it comes in. But no, it doesn't matter which one you apply to if you create a new image. If I did not create a new image, it would create a new image on, it would like replace the image of whatever I just had placed it on. All right, so let's get rid of this guy and we'll rename this HAL for HA luminance. Now, we can go ahead and just do an HA LRGB combination right here, okay, with this. And let's just see what we get when we do that. So again, our LRGB combination. Check these guys and apply.
Ah,
Let's see. So from there's before and there's after, okay?
Stu, when you do the LRGB combination,
Mhm.
turn off the RG and B, and that automatically has it pick up the RGB image? Is that how it works?
So LRGB combination, what it is, it's really a combination of the lightness plus the chrominance, okay? And so what we're doing when we doing is we're assigning what the lightness is, and then when you uncheck the RGB, you're basically placing that lightness on top of whatever chrominance you had.
So if you had two chrominance images up, you'd somehow have to select one or the other.
Correct.
Okay.
All right.
And
So
it's the selected image that it applies the.
right. And so
luminance
what
to?
I did is I dragged it to this image. Okay.
Okay,
Yeah. So
Got
when I
it.
do it, I'll show you again. So here we are.
right.
HAL.
So you dragged it to the RGB image.
I
I
dragged
see.
it to RGB. Now,
Yeah.
to me, this looks a little hot. So one trick that you can do is you take your HAL image and put a and compress it using HDR multi-scale transformation. Now, you're not going to like this result, but I'm going to show you what happens if you do it. So you do this, do HDRMT, and what it does is you see this area here. Let's go before. God, I hate this flyout. Before, after, before, after. So it compresses it. The problem is it also kind of deals with the stars. So in order to do this properly, we need to build a star mask. So I built the star mask here, but the way I did this, I had to do different star masks with different sizes. So I had this star mask that I used, and then I had not that one. This star mask that I used. And I think I had a third one as well. And then what I did is I did the same thing where I did max, star mask 1, whatever. So you build your star masks, and then you can create a master star mask based upon all your other star masks. So you don't have to do all this in one. So this is a pixel math expression of 3 different star masks built together. So I'll take that star mask, I'll apply it. And if you want me to go through how to build a star mask, I'm just assuming that a lot of the stuff you know, but if you don't, I'm happy to do it. So what we have to do with the star mask is invert it, because we want to actually protect the stars. So there, we're inverting it. And to invert, you do Control-Shift-I. So we're inverting the mask. And now let's run HDRMT again. Let's see, do we run it before? Yep. Let's run it again. Where did it go? There it is. And I just use the default at layer 6. You can choose layer 7, layers 5, they give different flavors results. And there, and we'll remove the mask here. And there's a compressed HAL that has its stars relatively protected. So again, we'll use this for our LRGB combination.
Stu, when you're protecting the stars, you were protecting them because the HA, high dynamic range LRGB thing, it had made the stars smaller.
Yeah, it basically, what it does is it compresses the stars and it makes them kind of pointy and kind of undesirable. So
yeah, well, that's a subjective thing. I would say the smaller stars are a little.
Oh, we're going to get to smaller stars, but that's not how I want to. That's not how I want to control the stars.
Okay.
We're going to get to that later. But I agree with you. But we're gonna control the stars in a little bit, but not now. So okay. Patience, patience, young Padawan. So again, we'll do the HAL, open up our RGB, apply.
Now this is with the star mask.
This was no. Well, this is not with the star mask. I took the star mask off the HAL because I'd already compressed it.
Oh, okay.
This is the compressed
It's
version.
a compressed HAL.
Yeah. Okay. So so here we are with an LRGB. So our next thing. So whenever you're looking at image, you go, okay, what do I want to do to this next? Okay, so what do I want to do this next? Well, what I want to do is bring out some of the color. So we'll just give it an initial saturation boost. So you open up curves, click on the saturation, and we'll go give a little bit of color there. So see, so there's, you know, adding a little color to it there. And it's a little muchly there, so we don't want that. Okay, so it's getting sort of where we want to go. But, you know, once again, you were talking about the stars. There's a lot of stars there. We want to try to control some of those. Okay, so let's pull our trusty star mask back up. Open this up. Apply the star mask, and this time we'll use the star mask as it is intended to just do the stars and not protect the stars, but we just want to attack the stars. And now we'll use morphological transformation. And you can do just straight erosion. I prefer to use morphological selection. It tends to give a little bit more natural result. I'm going to do a little bit more here. Here is an amount of 25%. We're going to go up higher. So if the selection is at 50%, then it dilates and it contracts and nothing happens. The lower you go, the more it will contract. So we're going to go to 25%, increase this to about 0.8, which will combine before and after, and we'll apply. And we can see that the stars, here's before and after, and the star mask kind of drops. See that? See there, before and after. We can give it a little bit more if we want to. I'll drop the amount this time. And maybe even one more. Okay. So, so we got rid of some of the star mass in here. Let's get rid of our star mask. So there's still some undesirable things in here, and a trick that I'll show you. So we have this halo here, which is under pretty good control, but I'm going to show you a technique to kind of decrease the intensity of that halo. So go to Script, Utilities, Game, and delete. So here we have an ellipse. Let's move it to the middle, and our halo is sort of here to about maybe there, maybe about there, okay? And we'll use a gradient mask and maybe try a star mask. These are all different types of masks that you can generate. And I can show you what a couple of the other ones look like too. Just you can see what they look like. So you hit OK. Wait for it to crunch. Okay. So this is a gradient mask. This is a star mask. This is a brightness mask. This is a binary mask. And this is a luminance mask. Okay. I think for this, let's see, I don't want to use this. Yeah, go away. I don't want the binary mask. Go away. Luminance or the star mask. So I'll choose the star mask for this time. So, and there's the gradient mask. Get rid of this too. All right. So apply the star mask. If we just are to look at the mask, this is what we see, okay? So to deal with this kind of bright halo, we've applied our galaxy mask, and our game mask, curves, hit the lightness button, L, and just drag it down just a little bit. See that? You know, and I probably could have gone bigger on the mask. So, you know, obviously just a little bit, just a little subtle decrease. So it's not quite so halo-y, like so. And really subtle. So you see them just right below the midline there. So apply. So again, we'll go before, after. Okay. And that technique is helpful, like if you're doing a corset and you're dealing with Altenac and you're having trouble with that halo. That's, you know, one technique to use it. Okay. Get rid of our galaxy mask. Let's see, what do we want now? Just looking at this, I think it could probably use a little more saturation, but I don't want to saturate the background. So I'll extract a lightness mask out of this by hitting extract CIEL. Click that. Lightness mask comes up. Here, apply. So to apply a mask, you drag it to right underneath. Mask is now applied. To visualize the mask, Control K, there's the mask, no mask, mask, no mask. And add a little saturation to this. Just a tad. See that? Just a little bit. Okay. Alrighty. So, what else can we do to this? So we're getting some little greenish stuff here I don't really quite like. So let's see what happens if I just throw an SCNR on it. So this is the noise reduction selective color. This little teal is still kind of there. Maybe a little bit better. Okay, so I think I would like to bring out maybe a little bit of the dark structures. So there's a script called Dark Structure Enhance. That's just Dark Structure Enhance, and I just use the defaults. Oh, it didn't like it because it had a mask applied. So let's take off the mask, try it again. All right, so let's have a look. So before, it's subtle. Before. So if we look just, let's say, here's an area here. Look just at this dark area here, before, after. See this little area here? Before, after. But we're starting to see some of that, you know, that nice sort of furry stuff in here. Let's add a little more color to it. A little bit. And then, it might have been a little too much, but that's okay. And then we'll, how about a little sharpening? Now let's, once again, protect the stars, because we don't want to over sharpen the stars. And I'll do an unsharp mask. Let's go down to here and take a look at this little cone area. It didn't really do much, did it? So this looks different than the first time I did it, and the second time I did it, and the third time I did it. So every time you do it might be a little different. I will pull up for you. Let me just save. Yeah, Mike, the stars are a little green. Mike just says, "Oh, the star's a little green," and they're a little green. I was sort of rushing through this. I'm going to save this project and exit project 1. Doesn't like that. So I'm just going to go ahead and put it here. System project 1, the second project. And let me just let it save, and I'll open up the original process that I did. So, any questions so far while this is crunching?
Hey, Stu, is there any relationship between the bright stars that have a white center and a green halo and some of these other field stars on the edges that just have a green cast overall?
The green cast, I think, was just because I was rushing through this. I'm going to open up the last project that I did. And it doesn't quite have the same green cast. And I can, I wanted to kind of power through the project itself that I did. And just let me just let this finish writing. And I can go through the various steps that I did. But the key things I wanted to show you was compressing, so combining the luminance and the HA, compressing it, and you do a LRGB combination with the luminance and the color, and then do a second LRGB combination using the luminance HA max. And then you can manipulate the colors how you want. I don't particularly like this process. There's halos here and it's a little over sharpened, but you know, once again, I was trying to rush through this. Once this finishes saving, I will show you my other project that I did. Oh, the other thing I wanted to show you was the trick with the galaxy mask and pulling down the lightness. That's a trick that Warren Keller taught me. You can also use the galaxy mask to do a non-elliptical one. So you can actually do multi-points to do an irregular field. I think I need a new computer. This is slow. The other thing I didn't do on this particular one was a nonlinear noise reduction because TGVD noise takes about, on my computer, it takes about 1.5 minutes. There are ways to combine S2 and O3 with the color as well. So let me close this. Yes, and let me open up my.
I didn't see the S2 and O3 masters on Dave's site.
It's, if you ask him for it, it's there.
Yeah, but for some reason he didn't put that out. I did ask him to put all the raw subs and the cal frames out, so people, if they want, can go through and do the pre-processing as well.
I'm just going to previous projects here. I'm not sure which one of these is the correct one. Hang on, let me just open a previous project. Edit, open recent project files. There we are. Okay, let me share screen again. The thing about these projects is that with all the swap files, they become pretty huge, so they can be multiple gigabytes. So, you know, they become a little bit more difficult to process. So let's see, here we are. Go back to the front. So this was my final effort. The time that I went, the last time that I went through it. And you can see that the green stars don't have that. I mean, the stars don't quite have that green cast that the other one had. But it was basically the same thing. But if we look at the History Explorer, I have a lot of little micro curves here. So like, for example, this is a little micro curve where I'm just manipulating tiny little parts of the histogram. This is a little micro curve. I'm just manipulating. See this little hitch down right there, where you can just pick a particular part of the histogram that you want to manipulate, and you can manipulate just that little part. You know, and so the advantage of a project is that you can look at exactly step by step what you did before, and to try to you can duplicate exactly what that step did. All right. Any other tricks you guys want to see? The important, what's really important is just to be really mindful of the histogram and being really mindful of, you know, how little manipulations will do this. And I'll just sort of show you here. So here we have our curves transformation. So there's our histogram. And let's say if I just want to isolate and do kind of this area here. Okay, so we look at this, we say, all right, so it's right about in here. Click a point. And we don't want to make this any brighter over here. So we'll click a point here. And we'll click another point here. And this is called an anchor point. So that way, when this moves up and down, see how this anchor point, this stays in the same place. So that's an anchor point. Similarly, down here, you can have, I want to leave this like it is, again with a little anchor point. So we can go to our preview. And if I just want to manipulate just that one level of brightness, so see there, manipulate it down, down. See how I'm just manipulating that little bit of brightness, like there, okay? And this is what's called a microcurve. So you can just see it very barely up above the midline. But these microcurves can be really important because a lot of times what people do is they try to really jam through those curves. And I found that you get better results if you just do these tiny little changes to the image at a time. So you can just kind of see this is down, this is up, just very slightly. So that's an example of a microcurve. One thing I didn't do is we can try doing a little local histogram equalization. I didn't think it needed it, but I'll just show you what LHE does. Usually you'll do this on the lightness component. Let's see, did it do anything? Yeah, so you can kind of see how LHE will affect it here, just in this area here. So there to there, just gives a little bit of extra local contrast. See that? From there to there. I think the stars look pretty good. They're pretty round. They're not overly saturated. I don't really quite like these little halos around it, but that's something I have to go back and try to figure out where those came from, and then try to fix it later. But overall, I think the goal of this was to be able to get the this fox fur into the Christmas tree part of the nebula, and this is how you do it. So you do the LRGB or RGB or LRGB combination to create a new chrominance. Take your HA, your luminance, take the maximum of them, compress it so it doesn't become too hot, and then do another combination. Okay, what time is it? So we're about 8 o'clock. That was about an hour. That was about an hour right on. This is where I just wanted to try to get an hour of this in. So, any questions?
Yeah, some people do post-processing in Photoshop afterwards. I don't think that's really necessary. Do you do everything in PixInsight?
I don't know how to use Photoshop.
Oh, good. All right. That's what I wanted to hear.
I started with Photoshop and I never grokked it. I never understood the whole concept of layers. Mike Chasen is a Photoshop whiz. He can throw you right through it, but I don't know anything about it. You know,
Some of us grew up with Photoshop before PixInsight, and you develop habits and things become very comfortable to do in Photoshop. And for instance, the curve transformation you just showed is very similar to the way it is in Photoshop. And you know, it's hard to get rid of your old ways and to move on, because it's when you're doing a picture, it's just sometimes easier to do it the way you're familiar with. Which
the one advantage Photoshop has is, you know, you can paint on it, and you can't really easily paint on this. And Juan didn't want that, and he didn't want layers. Rogelio RBA, who some of you have his book already, Mastering PixInsight, I think it is. He's going to be creating a script that will allow you to basically make it more Photoshop-like with layers and painting and stuff like that. You're gonna have to buy it because you know.
So that script won't be incorporated. You'll have to purchase it.
Yeah, I think you have to purchase it.
Yeah.
At least that's how he's still working on it. If you follow him on Facebook, he's talked about it, you know, here and there. So there are things that I like about this process, things that I don't. What I do like is I like the contrast on it. I like the blend of colors. I think the blend of colors are pretty good. I don't like how these stars kind of have little halos around them. That's, I think, an artifact of the hydrogen alpha stretch. Let's have a look. Let's go back forward. Yeah, so that's an artifact of the hydrogen alpha stretch here. So I have to figure out where in this. So it's from here to there. It was somewhere with the, this is where we did my HDRMT. So when I did my HDRMT, you know, my compression, it compressed this area here. So what I would have to do is basically build a better mousetrap, you know, build a better star mask to expand these stars a little bit better. But that's the one thing you can do is if you find you have a result you don't quite like, is go back through step by step and say, all right, where did this little artifact that I don't like come in? And you can look here, and here's the History Explorer. So here's our pixel math, and then here's our HDRMT. So we go from the pixel math, there's the HA, adding the luminance. I didn't create a new image on this one. And then our HDRMT, and sure enough, this is where those artifacts come in. So now knowing this, what I would do is I'd go back and I'll say, all right, I don't like where this is going. Let me try to build bigger star masks and, you know, maybe feather them a little bit better so I don't quite get that thing. And there's also a little de-ringing thing which we can try. See how that works. Let's click that. Maybe that'll do work. And let's zoom in again. It's actually a little better. A little de-ringing. There, oops, to there. And so that's a little bit less. So this is with the de-ringing checked, and this is without the de-ringing, and so it's a little bit more. See that? So do this again. I'll click the de-ringing, maybe increase the large scale a little bit. Do it. Yeah, maybe not. Anyway, you get the idea. So the trick is just to kind of fart around with it, find where it is you had the artifact, go back, fix that step, and then go forward from there. Let's see. Other.
Hey Stu, can you go over that game script again?
Oh, yeah,
The
sure.
Script and talk
Game's
about how
cool.
you did the thing where it wasn't just a round shape.
Yeah, that's a cool script. I love that script.
Yeah.
So utilities game. So it keeps there. So let's do a multi-point script. So let's go to multi-point, hit add. So click the first point there, and let's do and then it'll ask for a second point. It'll go there, and your third point will go there, and you can go like this, and you can do this, and then this, and then this, and then this. Okay, and then let's say like this, and then let's do yay, and like that. All right, and let's just do a binary mask so you can see what it just looks like. And so there, see? So we sort of drew that. So it's a way to sort of draw a figure, and you can make a mask, and then you can do fancy stuff if you want by convolving the mask. So whoop, like this. Make yourself a fuzzy mask. But that's how that works. And so it's neat for kind of irregular structures that you want to mask out.
Very cool. Thank you.
And so, you know, just let's review here, utilities game. So you have ellipses and multi-points. So the multi-point is you can just create whatever shape you want. Ellipses is just the ellipses. Okay. No, don't want to do that. All right, what else?
Anybody else got questions? Does anybody else process this image along with Stu? Didn't ever hear everybody speak at once.
The S2 and O3, there's not much data there, so it's not really worth farting with. There's a little bit of data there, but I don't think enough to make a difference.
Yeah. Well, the data is out there, and I think we can all access it and do our own processing on it.
Yes.
I have to admit that I took a little bit of time and just did a quick try on it, doing something that I do quite a bit of narrowband, and so often what I'll do is to use the because the H alpha is always the strong channel. I'll often use H alpha as the luminance, and then H alpha is red, and L2 and O3 is green and blue. And I'd never tried that with RGB, and in fact, I didn't really create an RGB image first. But if you'd like, I can. If you want to let me share, Stu, I'll show you what the result is. It's very simple processing. It didn't really take advantage of many of the fixed insight features, but I will I'll let you see what it looks like, and you can tell me what you think of it. Did I share the wrong screen, or do you see a?
No, see it. We see it.
Yeah. Okay.
So what did you do to this? How did you process it?
Okay. What I did was basically I just used LRGB combine, and I used for both the luminance and red, I used the hydrogen alpha, and I used G and B for G and B. That's how I got the basic combination. Then I did a background neutralization and stretched it. I then went to my comfort zone, that is Photoshop, and did some things in Photoshop to enhance it. The stars, you see the stars are, there's problems with the stars. They've got a little bit of a blue halo, but they started out as very green, and I had to use Photoshop to make the star colors even as good as they are. And you can see there's big halos around them, so that's not good. And I think I could have, had I made the RGB image instead of just using green and blue and H alpha, I might have gotten more realistic stars. But you can also see there's quite a bit of noise in the nebulosity, and I didn't do a noise reduction in PixInsight or anything. So the processing was quite simple, and just took me a couple hours, and that's how it turned out. It sure makes the H alpha more dramatic, and I'm not sure whether that's aesthetically what you want to do or not, but it emphasizes the H alpha quite a bit.
Right, well, people were asking, where do you get the game script? And I put it in the chat. And that's the website. And stick that. You go to I'll share again. And I'll show you where to put it. So you go to let's see, resources, updates, managed repositories, add, and then you put that URL in where it says add. And it's the skypixels.at hvp_repository. So just stick that in there. And then go ahead and update PixInsight, and all these cool scripts that Hartmut wrote will show up in your scripts.
Mm-hmm.
Does anybody have a comment on my picture? Do you think it's too glary, or?
I thought it was a little overly hot in the HA.
Yeah, it certainly is. I guess it's a taste thing, I suppose. Somebody who isn't familiar with astrophotography would think it was wild and dramatic, and somebody who has really seen a lot of and worked on a lot of astrophotography would say it's unrealistic. And so I don't know.
We love HA.
We love HA.
Right. Yeah, sure. When it yeah, you can certainly emphasize it and make quite an image out of it.
That's modern art.
Yeah.
Art. Okay,
Yeah, exactly.
I do have a question.
Sure.
Stu, you said you don't like to use PCC.
Yeah.
And we all did a big group exercise of imaging the Pelican and, rendering it as best we could. And I decided to say, well, I wonder if I got the color right, because some color tints show details maybe better than the real PCC colors. Mm-hmm. So just today, this morning, I went into PCC and did the whole process, and I noticed that PCC gave me a slightly different color than the one I'd chosen for the Pelican, because I liked it a little bit more yellow for contrast than PCC wanted it. But PCC also picked up some, apparent nebulosity around stars that I would just prefer to black point out. So why is it that you don't like to use PCC?
I don't know. Personal preference, I guess. We can try it and take a look at the difference. Let's do it right now. So let me go back to sharing in. All right, so let's go back all the way back. All right, so here we are here. Here's our background extraction. Okay, so let's clone it. So this is background neutralization, color calibration. Okay, so there's our color calibration. This is that. Now let's go to PCC and, oh crap. And somebody's going to have to tell me what the image scale is. Photometric color calibration. So search coordinates. Let's see, acquire from image. Okay, and what's our focal length of tarot? Anybody know offhand? Pixel size is 9, I know.
I don't think it's that much.
Let's try 1500 and see if it'll.
It's longer than that. It's
Let's go for 2000 then.
yeah, 2 or 3,000.
What?
2 or 3,000.
Okay, so let's do that and let's see what happens. And so it'll take a little while. If it doesn't like it, it'll tell us it doesn't like it. This is the other reason why I don't like PCCs, because I'm impatient and it just takes a while.
Can I redirect for a minute about another cool script that took PixInsight by storm, and that was that StarNet one where it eliminates stars? Are you a fan of that script?
Let's see. Let's see how this works first. So, all right. So it has a pretty good thing here with white balance. All right, so that you'll get this. We'll show you how linear your white is. And let's see, take this out. So here's with PCC, and here's with they're pretty close. They're pretty close. Yeah, StarNet. It's okay. I think it's, I don't like starless images, so I don't use it much. I do have one starless image that I can show you. I did use it, but it's not something that I normally use, just because I'm just not a fan of starless images. But if I can find it here. Albums, photography, and here it is. Share screen. So this is one that I used StarNet on, and this is Malot 15 without the stars, and it's kind of leaves these artifacts around here, but I kind of left it because I thought it looked kind of cool. But generally, I don't use it. But that's an example of the use of StarNet.
Cool, thanks.
Trying to think of any other tips. Sometimes when I do HDRMT, so back this HDRMT script process is I will apply it to a luminance or lightness or whatever I'm working on, and then if it's too compressed, then I'll do a pixel math of the original plus the combined, and I'll use a pixel math expression like this, where I'll go, so A times original, whatever that is, plus inverse A times HDRMT. Yes, we don't need parentheses.
Do you want to share?
Oh, sorry. Yeah. Duh. Okay, sorry. So A times original plus inverse A times my HDRMT. And then when you do the symbols, you can go like A equals 0.5. And then what it'll do is, you don't need, it's whatever your original is in your HDRMT. And when you do the tilde, that's like 1 over A. So A times, plus 1 plus the 1 over A. So if A is equal to 1, then it'll just do the original. Okay. So that's just another trick that I'll use sometimes.
Stu, is there a way that, you just talked about the syntax?
Not 1 over A, I'm sorry, 1 minus A, not 1 over A, 1 minus A. Okay. Sorry about that.
But is there a way to is there a listing of the syntax that the pixel math uses someplace that you can get to?
Oh, I'm sure there is. There's, so what I just did, and so the tilde, so it's A times original plus 1 minus A times HDRMT. So this 1 minus A. So if A were equal to 1, then 1 minus 1 is 0. So it will just have the original. Okay. If A is equal to, if I have A equals 0, then it'll have just the HDRMT. And if I have A equals 0.5, it'll be 50-50 of each.
Mm-hmm.
Okay, you see how that works?
Yeah.
And another way of doing 1 minus A is a tilde. So tilde A, that's a tilde of something is 1 minus something. And I can demonstrate that. So let's just take our luminance here and go back forward. I'm going to clone the luminance. I'll do an HDRMT on the luminance. So there it is. So there's before and after. And then let's do our pixel math trick. So we'll do A times luminance plus tilde A times bloom clone. And let's do symbol. Oh, that should be up over here. Symbol A equals 0.5. Okay, so we'll apply this here. And so it basically took a 50-50 of this and the luminance, okay? And now if we want it to be a little less hot, we'll go 0.3. Oh, see what I did there? So there, this will be 0.3. Or did I do that right? Yeah. And if we do it A equals 0, so A equals 0, then it stays the same. A equals 1. I don't know what's going on. Anyway, that's how you do it. So so do the so you have your, it's a way to blend images. So, and you can blend images however you want. So this, I'm just doing an A, you know, A times the luminance, and then 1 minus A times the luminance cloud, and you can blend them to whatever setting you like.
Yeah.
All right. Any other questions?
Well, we've got a few more minutes. If there aren't any questions, Stu, is it, what else would you like to show? Are there other things that that we ought to understand better about PI and processing?
Well, I mean, yeah, sure.
The big topic.
Yeah, right. Yeah. What do you want to know about a PM browser? So, it's the things that I wanted to show you were kind of doing the microcurves on the using the curves transformation, how to combine the HA with the luminance, how to use the game script, and how to build a star mask. We didn't really talk about totally how doing a star mask. We can sort of show how to build we can sort of show how I built a star mask here. So we'll go to star mask. Let's apply it to this image. And this is why I didn't want it to go through it, because each star mask on my computer takes a little while. I think I need a new computer. If somebody wants to buy me a new computer, I'd be awesome. Thanks. Yeah, this is an old i7. I know I understand that there's a lot faster processing out now. State of the art from Costco at the time. Okay, so that's a pretty good, right? But let's do another one with a high scale.
So you're going to combine those masks, the two masks?
Correct. I'll just kind of show you, and then I'll show, once this is done, I'll show you another script that's kind of cool. I didn't do deconvolution on this image. I didn't think it really needed it. Deconvolution to me is best on like when you're doing like galaxies and stuff, but I tried it the first time I processed it. I didn't really like the deconvolution results, so I decided not to do it. But that's, again, every image is different. Every image you have to decide, what do I want to do to the image now? What's next? And if I don't like what I have, what did I do wrong? let me go back and figure out what I did wrong. Okay, so there's that. And then we'll go to script, utilities, advanced star mask. Oh, I don't want to do a star mask on the star mask. Let's do it on there. Script, advanced star mask.
So what's the difference between the two masks you just created?
Okay, so so this advanced star mask will just create smaller stars. This one, not a lot, honestly, between the two.
Mm-hmm.
But I was just going to give you an idea of kind of what I'm talking about when I talk about building a star mask. So here we have star mask. We'll do pixel math. We'll do max loom star mask, comma, star mask 2, comma, star mask 3. We can apply to one of these guys and boom. Okay, so now it's sort of a combination, the maximum of all 3 of these star masks. And that's sort of how I did that last star mask. Okay, yeah, I don't want it. Alrighty. Other cool scripts that I'll use sometimes. Talked about game. Advanced sharpening, I've never really had really good luck with. We can kind of see what it looks like. We try advanced sharpening.
That is script.
Yes, let's try it. Let's just see what happens. So, advanced sharpening, sharpen. This is another Hartmut script. So, yeah, you can kind of see how it's, so here's a before, here's an after. The stars are kind of sharpened up. I don't like it, but, because all these little guys are just sort of like little pinpoints that come up. But you can kind of see how, how these things work. So, that may appeal to some people. It doesn't really appeal to me, but to me, it looks a little overly sharpened. What else? The curves transformation is very powerful. So we talked about saturation. We talked about the lightness, which a lot of people aren't aware of. They usually just use the RGBK, but the lightness just deals with the lightness component of the mask. And then this is the hue slider, which we won't really use in broadband imaging, but in narrowband imaging, you'd use this hue slider a lot because you're adjusting, you're basically adjusting your SHO palettes. This is C, it's called colorfulness. It's kind of like saturation. Somebody who understands the color wheel and all this color stuff could explain better than I can what the difference between colorfulness and saturation is. To me, they kind of sort of do the same thing. We can kind of see what colorfulness does to this guy, so there's colorfulness there. Obviously a little bit too much. And then we go to saturation. Yeah, this kind of makes it a little more purpley, which I don't like. So maybe the colorfulness is a little better. Maybe colorfulness is a little better. It's still a little purpley. Somebody who sort of understands, the color wheel and the different types of color spaces can explain this a lot better than I could. I just sort of, I kind of move a squiggly and don't like it. And I go backwards on the squiggly. That's kind of my method of processing. Generally, when you do high dynamic range multi-scale transformation, you generally want to follow it up with some sort of curves transformation or LHE, because HDRMT by definition will flatten out an image. But with this particular image, I did not do that because we were actually trying to flatten it out because it was too hot. But if you use the HDRMT on an image, generally you're going to be using LHE or curves transformation after the HDRMT, and that's in Warren's book. For the morphological transformation, like I said, I prefer morphological selection, but we could just have easily done just erosion. You know, that will more or less do the same thing as the morphological selection. I like the look of the morphological selection a little bit better. We didn't talk about range masks. This MLT star, this is something from Rogelio. We can actually create a star mask without using the star mask script. So his feeling was that all your star data is going to be in like layers 3, 4, and 5. And so you X out all the rest of the layers. And you can you can basically extract the star mask there. Now here, we didn't really have enough, so I would go back and maybe redo this layer, see what I get in there. A little bit more, see that? A little bit more stars coming out. Let's get layer 7. There's some pretty big stars in here. And so it's just a way of, a cleaner way of getting a star mask that basically will do a similar thing as what I was doing before. But you can just, you can extract the stars by using multi-scalar linear transformation. And if we wanted to add more layers, we can add more layers. So here, add another layer, put layer 8 in there. Oh, didn't mean to do that. Now let's try it again. Nah, I fucked it up. But anyway, you get the idea. So you can, without putting any parameters, you just basically tell it what layers you want it to extract. Oh, that's why, because I have the residual layer. So, so I just wanted to extract layers 3 to 8. And now we're starting to get a little structure here. So we don't want that structure because it's not part of our star mask. So back off on that, take away layer 8. Still a little bit of structure there. But you get the idea. This is just another way to build a star mask. Using just MLT, multi-scalar linear transformation. Yeah, so that's pretty much all I got. I mean, I'm happy to answer any questions or run through anything else.
Yeah. Well, I think that's very helpful for a lot of us that who are into PixSight a bit, but really are far from understanding all the capabilities and features.
I didn't say I understood the capabilities and features. I said I move twiddlies until I get what I like.
Yeah. Yeah, there are different levels of understanding.
There's very much different levels of understanding. You know, you want somebody who really understands it. You know, you talk to Ron, Warren, Adam Block, Rogelio, people like that. You know, they can tell you exactly what's. I mean, Adam especially can tell you exactly what's happening underneath the hood. Yeah. You know, and his videos are very, you know, very detailed. And if that's what you're interested in, you know, go to Adam Block's videos. Yeah.
Well, that's the thing. There's so much literature and videos and sources of information on all the different features in it that you can spend months and months just just watching YouTube on it, I think.
Yeah, be careful with random YouTube videos though, because I find that a lot of the YouTube videos that I see out there show bad technique.
Mhm.
And so I really recommend that, and I mean, I don't get paid by any of these guys, right? But I really recommend learning from the experts because they'll teach you the right way. And if you learn it the wrong way ahead of time, it's sort of hard to unlearn it. So beware of the random YouTube videos. Adam Block, IP4AP, which is Warren's site, the Masters of PixInsight, which is the workshops that they go through. The IP4AP is Warren's, his regular tutorials.
Right.
Warren's book, Rogelio's book, is the most up-to-date book that's now out there. Many of you have it, I know. Warren is going to do a 3rd edition of his Inside PixInsight book that he and Ron Breacher are going to start working on. So I would go to one of those, and I do recommend the one-on-one sessions because you'll learn a lot.
Okay. Anybody else got questions? Well, Stu, I can say, yeah, great meeting. And we certainly appreciate your expertise on this and
No worries.
want to keep
Anytime.
you involved in the things that we're doing down here in San Diego.
Yeah.
And really,
Yeah, I actually, well, I've been down there. I was down there for a month and I just got back and I'm coming back down again, but you guys aren't meeting in person yet. So it doesn't really
yeah, on Zooms and
Yeah.
probably will be for the, well, we don't have any indication yet that we've,
Yeah.
that the path to
But
live.
next time I come down, I may go out to TDS with Mike because he's having some collimation issues, and trying to collimate a scope when you're all alone in your observatory at night is really boring. So I figured I'd go and I'd be in his way and kibitz and say, So may see you out there.
Okay, great. Well, thank you very much.
My
And
pleasure.
we'd love to have you again. And
Yeah.
Anytime.
Absolutely.
Great. So,
Thanks, Stu.
My
Good
pleasure.
job.
Thanks, Stu. We always learn a lot.
yeah,
I'm happy to hear it. Thanks. But I learned from the experts. I'm just sort of regurgitating stuff that I learned. So, make sure you check out those experts too.
okay. Very good.
All
Thank
right.
you very
Thanks. I'm gonna plop.